Given that x squared plus 8x minus 3 over x plus 2 is equal to 8x plus b plus c over x plus 2, find the values of the constants a, b and c. So when we do this question, we can see that we need to divide by x plus 2 so that we get this form of the fraction. And we can do this by doing long division. We've got our x squared plus 8x minus 3 here and our x plus 2 here. And then we need to see how many times can x go into x squared, and that's only what x times, right? So you write an x here, and then we can multiply x by x, which gives us x squared. 2 times x is 2x, and then you minus this, and that will give you 0, and then 8 minus 2 gives 6x. And then you bring this minus 3 down, and you get 6x minus 3. And how many times does x go into 6x? 6 times. X times by 6 gives 6x, and 2 times by 6 gives 12. And then you obviously do minus again, and 6x minus 6x is 0. Minus 3 minus 12 gives minus 15. So we end up getting our answer as x plus 6 minus 15 over x plus 2, as this is our remainder. And you can see it kind of follows this form. We've got a is equal to 1, b is equal to 6, c is equal to minus 15. Hence, using algebraic integration, find the exact value of this integrated, where 6 and 0 are your limits, giving your answer in the form a plus b ln 2, where a and b are integers to be found. So we're going to use our format of this fraction from earlier, x plus 6 minus 15 over x plus 2. This will make integrating it so much easier. So first what we're going to do is we're going to integrate our x. We know that x is just x to the power of 1, and then when you increase the 1, it is x squared. And then we need to do x squared over 2, so we get half x squared. With 6, there's no x, so we just add an x, and it becomes 6x. And then to do this minus 15 over x plus 2, we use this sort of formula. So we know that it's minus 15 times by 1 over x plus 2. Our a is just 1, so it can just be written as 1 over 1. That doesn't change. So now we just have ln x plus 2 as our a, x plus b is x plus 2, times by minus 15. So we've got minus 15 ln x plus 2. And then we obviously add our c at the end. However, because this question needs to find the value using these limits, it doesn't really matter. So we put the 6 into the x, and we get half 6 squared plus 6 times 6, and then minus 15 ln 6 plus 2, and that will give you 18 plus 36 minus 15 ln 8. Now we can do the same for 0. Obviously our x terms just become 0, anything multiplied by 0 just gives 0, so these cancel out. And then you have minus 15 ln 0 plus 2, which will just give you minus 15 ln 2. And then we need to minus both of these from each other. And obviously our 18 plus 36 gives 54. And then we get this answer, which is 54 minus 15 ln 8 plus 15 ln 2. However, to make things a lot easier, we can actually change this 8 into a 2. We know that 8 equals 2 to the power of 3, so we can rewrite this like this, 15 ln 2 cubed, and then we can move this power to this side into the front, so we get 15 times 3 ln 2, which gives you 45 ln 2. And then we do 54 minus 45 ln 2 plus 15 ln 2, and obviously we know minus 45 plus 15 gives 30, so we do 54 minus 30 ln 2, and our a is 54 and our b is minus 30. Figure 1 shows a sketch of part of the curve with the equation y equals 1 over root 2x plus 5. The finite region R, shown shaded in figure 1, is bounded by the curve, the x-axis, and the lines x equals 2 and x equals 5. Use a trapezium rule with 3 strips of equal width to find an estimate for the area of R, giving your answer to 3 decimal places. So the first thing we need to do is find out the width of each of these 3 strips, and we know that we have 3 strips, so we can set n to 3. And then we need to find out the distance between the strips. So we know that B is equal to 5 and A is equal to 2. And we can use our general formula to find the width, which is this distance, which is B minus A, divided by your number of strips. So we do 5 minus 2, which is 3, divided by 3, and it gives you 1. So each strip is equal to 1. And then we can work out our x values for each of the strips. So we have x0 to x1, so 2 to 3. So we've got our x0 is 2 and our x1 is 3. And then as each strip is equal to 1, you just keep adding 1. So x2 will equal 4. We've got 4 somewhere here. And our x3 is 5, and we stop there because it's between 2 and 5. And we can actually see we've got 3 equal strips. And now what we need to do is we need to find the y values for each of these x values. And how do we do that? We just put this x back into this equation and we can find our y. So this is our equation, which was over here as well. And then we put our value of 2 into this equation. And that is root 2 times 2 plus 5. And that just gives you 9, as 4 plus 5 is 9. So you get 1 over root 9. And y0 is 1 over root 9. For x1, we just put 3 back into the equation. That will give you y1 equals 1 over root 11. And then you can do the same for 4 and you can do the same for 5. Now we're going to use our formula. The area is approximately equal to the height, which is 1 over 2, brackets y0 plus y3, so the first y and the last y, plus 2 times by y1 plus y2. We can put our values into the equation here, and that will give you 0.875 to 3 decimal places. Okay, use calculus to find the exact area of R. So this is our equation from earlier, and we can simply rewrite this as 2x plus 5 brackets to the power of half, which will give you the square root, but because it's 1 over 2x, root 2x plus 5, we have to add the minus. So you'll get 2x plus 5 times, 2x plus 5 to the power of minus half. And then we use this formula, and we know that f of x is our 2x plus 5. Our n is minus half, so we do 2x plus 5, n plus 1, so half minus half plus 1, which gives you half, over minus half plus 1, which is just half. But as you can see from here, we're not just dividing by half, we're multiplying this half by 2. And why are we doing that? We're doing that because if you differentiate this part of the bracket, it gives you 2. So you need to multiply this half by 2, which obviously just gives you 1. So this will just cancel out and you'll just get 2x plus 5 to the power of half. And then obviously our limits are 5 and 2. And we put this back into this equation, and then we put our 5 into the x, and that gives you root 15. And you put your 2 back into the x, that gives you 3. And obviously you need to minus this from this, so you get root 15 minus 3, which is your exact area of R. Okay, show that 2x bracket x plus, 2x times root x plus 2 integrated with the limits 2 and 0 gives 32 over 15 bracket 2 plus root 2. For this equation, we'll just use some substitution. We'll set u as x plus 2 because this root is quite difficult to deal with. And then we can differentiate this, and x differentiated is just 1. And then if we multiply by dx on both sides, we get du equals dx. And then we can rearrange this to get x on its own, so x equals u minus 2. So obviously, as we're doing this in terms of u now, we're going to substitute the u into the x. We need to also change these limits. So these are currently in terms of x. And we know that u equals x plus 2. So we do 2 and 0. And then to get the u, we do 2 plus 2, which is 4. and 0 plus 2, which is 2. Sorry, I feel like it's a really complicated way of explaining it. But yeah, you've got your limits as 4 and 2. And then we can obviously put our x back into this equation, which is 2 bracket u minus 2 root u minus 2 plus 2. And this cancels out, this minus 2 and 2, so you just get root u. And then we can rewrite this as 2u minus 4 times square root of u. And then we can put this back into this equation here. And we can rewrite root u as u to the power of half. And then we can just expand this out. And now all we need to do is we need to just integrate this as normal. You increase each power by 1 and then you divide by the new power. So we get 2u to the power of 5 over 2 minus 4u to the power of 3 over 2. And then divide this by 5 over 2 and this by 3 over 2. And that will give you 4 over 5 u to the power of 5 over 2 minus 8 over 3 u to the power of 3 over 2. And then we can put our limits back, and we just need to put the 4 back into this equation, and then the 2 also back into this equation. And when you do each of these, it gives you 64 over 15 minus 32 root 2 over 15. And then we need to minus these from each other. And obviously, because there's a minus in front of the 32, it will turn into positive, so just add them. And that gives you this. And then we need to write this in this form. Obviously, you can spend time trying to work out how to factorize it and all of that, but it's only a 7-mark question, and you can just directly write this answer underneath here, and that is it.